So for today's class, if you're at this video, you've already finished these igneous rock vocab words and this chart on your notes here. That using those blue books that were up front, so those should be done if you're at this point. Um, Before we go any further, if you're not done with the sedimentary rock vocab here on the second page, you're going to want to do those too. You need to finish those. Those should be done by now, but in case you might have missed a day or something like that, these need to be done too. So if you could go through and do those right now and then come back to the video if you still have time. But if you're done with both the igneous rock vocab chart, the sedimentary rock vocab chart, let's go down to the metamorphic rocks. Don't worry about the vocab words for now. Let's go down to our three headings underneath the table of notes, examples, and characteristics. And today we're just going to do the notes and examples because I just want to kind of keep this quick. There's not a lot to write for the metamorphic rocks anyways. And we'll do characteristics tomorrow when I am back. So if you haven't already, take out your Chromebooks. Well, obviously your Chromebook's open, but go ahead and open up this document for the rock notes 6H. And then let's scroll down to the metamorphic rock page. So let's get started here on our metamorphic rocks. Wait, what's that music? No, that is not the music to change classes. It's the music of David Bowie and Queen singing Under Pressure. Why is that playing? Well, let me tell you. Metamorphic rocks. The way to remember how they form is like two words: heat and pressure. And it sounds a lot alike from David Bowie's Under Pressure. So I think we're just going to let this play as we take our notes, huh? Little under pressure or heat and pressure. All right, let's go through our notes for metamorphic rocks then. Okay, so underneath your notes section, only one bullet point here right now to type in. The other things in black you do not need to write. Okay, that just kind of describes a little bit about how metamorphic rocks can form. But in general, we're just talking about how they're formed by heat and pressure that changes existing rocks. So, heat and pressure, which is why I'm playing the Under Pressure song, which is like my longest joke I think I've had in my whole teaching career. I think I've been telling this joke for like 15 years. But the key with metamorphic rocks, guys, is that it's not just the heat and pressure. It's what is the heat and pressure being applied to? And it's to rocks that already exist. And these could be any rocks. They can be sedimentary rocks. They can be igneous rocks, intrusive, extrusive. They even could be metamorphic rocks that change into different metamorphic rocks because of this heat and pressure. They literally go through a change in the alignment of the minerals and things to become this new rock, this metamorphic rock. And it's all because of this heat and pressure. So you can imagine the amount of heat and pressure that is required for this to happen is pretty tremendous. It's great. And so that type of heat and pressure really can only come from one place. And if you remember our layers of the earth unit, you should be thinking deep within the earth. Below the surface is going to be the only place where we get that type of heat and that type of pressure that's going to do that to a rock. Okay, next bullet point under your notes section is our subgroup, foliated. Foliated metamorphic rocks have a lot of the mineral mica, which was number 3 in our bags. And because of that, it gives them a little bit of a sparkling surface. But that's not the only thing. For foliated rocks, what makes them stand apart from the other subgroup is that we usually start to see layering or banding. Now, remember, layers was one of the characteristic for sedimentary rock that we just did yesterday. Oh, and the song's over. Okay. Oh, that's a good song. That's a classic. Okay. So, anyways, you have layering like we saw with sedimentary rock. Banding looks a little bit different. Okay. Banding is literally like almost like stripes going across the rock. Okay. And I'll show you some examples when I'm back tomorrow of what this looks like. You can kind of see it here in this piece of what's called gneiss. That's how you pronounce that. It's a German word. The G is silent. It's pronounced nice, not gneiss. It's nice, like, oh, nice rock. So I'll show you that. But the one that slate looks a lot like a sedimentary rock because it has the layers kind of like I showed you with that piece of shale yesterday when I walked around and showed you the shale, that gray shale that had the layers that looked like they were just stacked on top of each other. Well, slate kind of looks like that. And there's a reason for that, and we'll talk about it. But first, let's put in our examples. There's 3 rocks here, but you only need 2. You need to write in slate as being foliated and gneiss as being foliated. Slate and gneiss. That's it. Do not use this one here. This is pronounced schist. We don't need to know that one. Slate and gneiss. So type those in underneath the examples part of your notes, and then go back to the notes part, the notes category. So, like I said on the previous slide, metamorphic rocks come from existing rocks. So they have kind of this weird relationship that's almost like rock, like being like rock relatives, where we see characteristics of the pre-existing rock that was there before it turned into a metamorphic rock. So for instance, the piece of slate, the reason I said it kind of looks like shale is because it used to be shale. Shale, when it goes through tremendous heat and pressure underneath the surface, turns into slate. And even though this piece might not look like it when I show you guys in class tomorrow, this piece of gneiss looks a whole lot like granite. And the reason that is because it used to be granite. Granite, when it goes through heat and pressure deep within the earth, granite turns into gneiss. So shale turns into slate, granite turns into gneiss. And those are like their rock relatives. All right, the easy thing for their other subgroup is that it's not another word. It's just foliated and then non-foliated. So under your notes, type in the red up here at the top as a bullet. And then non-foliated metamorphic rocks usually have this random sparkling pattern. They are not in bands or stripes. Okay, there is random pattern. And they usually have really large crystals in them. Okay, so they can really sparkle. 2 examples, once you have that typed into your notes, to put in. Both of these rocks we're going to use as examples. You don't need to know it as white marble. We're just going to do kind of like the general marble. So marble is one of your examples of a non-foliated rock. Marble, non-foliated. And this is pronounced quartzite. Quartzite. Okay, so marble has to come from a pre-existing rock, and it comes from the sedimentary rock limestone. And it kind of has that same sparkling surface like limestone does, especially the limestone that is lighter because it has lots of halite in it, and it looks almost kind of like almost bordering like a white or a light green. It's really easy to see how that could turn into marble when it's buried deep within the earth and undergoes the heat and pressure to turn into marble. Quartzite has the rock relative of sandstone. And if you know what sand is made of the mineral quartz. It makes sense that quartzite then is made from sandstone, and that's why it's called quartzite. So when you see a sample of quartzite, which I will show you tomorrow, you can actually see some of the grains of sand, or that look like the grains of sand, in the quartzite. So again, it kind of it makes sense, and there is evidence to show, oh, this used to be sandstone before it went through heat and pressure, or this marble used to be limestone, or the gneiss used to be granite, the slate used to be shale. Okay, so the only thing left then is the vocab chart for Metamorphic, which we're going to do tomorrow. I don't want you to do it today because it's a little bit confusing because those words aren't bolded in those little blue textbooks, in those little blue books. So I'll show you that tomorrow. And then we'll do the characteristics tomorrow because I think the characteristics, it makes more sense for you to see the samples that I have for you, and then for us to type in the characteristics of metamorphic rock. But since I'm not there today, I can't show you the samples, and I don't really want them out when I'm not there. So we'll look at them tomorrow. Okay. So this is it for the notes part. If there's still time left in class, you can work on a review game where you're putting in questions about the 3 classes of rock and some of our examples and all of that. Some of you might have started this last week, so you can continue working on it. If not, you can choose any platform that you want, GimKit or Quizlet or Kahoot, quizzes. You make it up. Make them good questions, though. Okay, make them good questions that we can legitimately play in class that is going to benefit us as a review. So you can work on that if there's time left. Okay, I will be back tomorrow, and I will see you then. Don't forget that your rewrites for your mineral test are due at the end of the day, Thursday. All right, have a good day.